a steel cross section interlock to each other to make this fence around your excavation. The fourth one, which called anchored retaining wall, actually we don't have enough depth embedded in your soil to make fixation for the retaining wall, so we need to provide another support at any location through the height of the retaining wall. So we can provide anchor embedded in the soil. Last time also we talked about what is the effect of soil on the retaining wall. We have something called active earth pressure and passive earth pressure. First, which direction, or where is the side of active, where is the side of passive? Go ahead and determine which side will push your retaining wall away from the soil. I think this soil will push this retaining wall in this side. So this is the active side and this is the passive side. Very important thing here, if you have water and if you have soil, what is the difference? Here is the surface of water. Here is the surface of ground surface. I'm looking for pressure at this point. I'm looking for pressure at this point. This point at depth H, this point at depth H. Remember, you are talking here about water, you are talking here about soil. At this point, we have pressure equal gamma water time H. And remember, this pressure may be vertical pressure, may be horizontal or lateral pressure, this side or this side or this side. All pressure in all direction at this point in water the same. Gamma water time H. That means if you have retaining wall and you have only water on this side, I can say, hey, your pressure at this point equal gamma H, gamma water H equal 0. Your pressure at this point equal gamma water time H. You have a triangle like this one. Because your lateral pressure will be the same like vertical pressure equal gamma water H. Any question for this point? We covered this point before in hydraulics, I think. But for soil, we have a little bit difference. Maybe the same procedure, the same situation, but a little bit difference. What you mean? Your pressure at this location equal gamma H, but gamma soil. Because you are talking right now about soil. Your pressure equal gamma soil H only for your vertical pressure. If you are talking about vertical effect of the soil or vertical pressure of the soil at this point, I can say gamma H, like water, exactly. But if you are talking about lateral pressure, this term for vertical pressure of soil. If you are talking about lateral effect, lateral pressure of soil on retaining wall, your lateral pressure will be gamma soil H, but times something called K. Your K may be K active or K passive, based on which side you are in. You got it? So I suggest, if you would like to determine what is the lateral pressure of soil, you have soil here. Okay, what is the gamma soil H? Then time K. What is the gamma soil H, then time K. What is the value here? What is the value here? And then draw your line. So remember, for soil, at any point, we have two different value of two different shape of pressure. You have vertical pressure, you have lateral pressure. Your vertical pressure at any point inside soil looks like pressure for water, gamma H, but this time gamma soil. If you are looking for the lateral effect will be smaller because this K smaller than 1. So your lateral pressure will be K, maybe K active, K passive, gamma H. In your FE exam, sometimes you have problem like this related to the geotechnical topic. You have a retaining wall giving phi for this soil at this point, at distance maybe 10 feet, your gamma soil is given, your phi is given, and the problem said what is the vertical pressure at A, point A. Sometimes they are asking for what is the lateral pressure at A. Same problem, but read it carefully. What is the vertical pressure at A? What is the vertical pressure here? Your vertical pressure equal gamma soil, which is given, time H, which is given. That's all. If you are talking about the lateral pressure of soil at this point, okay, your lateral pressure, this is the vertical one, lateral pressure equal gamma soil time H, but time K active, because this soil will push this retaining wall away. So it's you are in the active side. K active, I think last time we talked about this point. Your K active equal 1 minus sine phi divided by 1 plus sine phi. Your phi is given, which is the friction in between particles of the soil. So 1 minus sine phi divided by 1 plus sine phi. I can figure out what is the value of K. Gamma soil is given, H is given. I can get my lateral pressure. You got it? You got it? Before starting to solve any problem or talking about retaining wall, this one is very important. What is the difference between pressure of water and pressure of soil? Both of them gamma H, but gamma H for vertical pressure. For lateral pressure in water, both of them the same, lateral like vertical. But for soil, no, your lateral pressure equal your vertical pressure times something K, which may be K active or K passive, based on which side you are in. If you are on the active side, your K active equals this term. If you are in the passive side, your K passive equal the reverse. 1 plus divided by 1 minus. Phi, angle of internal friction of the soil. Let's see. Sometimes we have on the ground surface people standing on this area. Sometimes, yeah, we have many people. If you remember this photo, what's going on here? We have cars. We have people walking, we have many things here, so we have live load, we have trucks, so we can expect something on the ground surface. So maybe you have retaining wall supporting soil and you have additional load on the ground surface. This load called surcharge load. Additional load on the ground surface. Okay, I don't care. My concept for lateral pressure of soil is calculate your vertical pressure, multiply it by K to get your lateral pressure. That's right. This one is vertical, this one is lateral. Okay, so if I'm looking for what is the pressure, lateral pressure at this point, and what is the lateral pressure at this point for this retaining wall supporting this soil. Okay, go ahead. What is the vertical pressure first? What is the vertical pressure here? Gamma soil H plus Q. I'm sorry. Yeah, we have additional load here. So the weight or the pressure of the soil plus the additional weight of the load. But we don't have H here. Do you have H for soil? No, this term will be 0. Your pressure will be Q. You are talking right now about vertical pressure. But if you are looking for lateral pressure at this point, you have to multiply your vertical pressure by K. What is the value of K? It should be K active. Because this soil will push this retaining wall away, so you are on the active side, or in the active side. If you are talking about this point, let's talk first, what is the vertical pressure here? What is the vertical pressure? Your vertical pressure equal gamma soil H plus Q, the additional weight. If you don't have additional weight, this term will be 0. If you have it, keep it. Okay, I have H for soil, yes. I have Q, yes. But your lateral pressure will be this term, gamma soil H plus Q, which is the vertical pressure, times K active. So I think I will have a value here, and I will have another value here which will be greater. Your pressure, something looks like this. One more time. If you don't have additional load here, just your ground surface without any additional load, I think your pressure at the first point will be 0. The pressure at the second point will be value, and you have a triangle. Do you agree? Okay, I like pressure. Pressure is indication for something pushing your retaining wall, but I would like to convert this pressure to a force. Force is good. Actually, this trapezoidal, I don't like, I'm not feeling good about trapezoidal because I don't know where is the centroid of this trapezoidal. So I will divide it to rectangular with force F1 and another triangle with another force F2. Do you remember something from hydraulics last semester? We covered this before for water pressure. Anybody remember? And we have something like this in the exam, I remember.
I think Colin does.
Anyway, so we have pressure, we need to convert this pressure to a force. Okay, your force equal this area. The second force will be the area of the triangle. Once you get your force, if you are here, I can say, hey, this force times this distance, and this force times this distance, I can tell you how much moment you have here. If you have your moment, I can design. If you know your moment, the value of moment, I can design. I can figure out how much is the reinforcement for this retaining wall at this location. Anyway, we are focusing on pressure right now.
Dr. Amy, can I ask a quick question?
Yeah.
Does the force help or hurt? Like the surcharge for load, does that hurt or help the retaining wall?
This load
Yes.
and this pressure will hurt this part of your retaining wall.
Okay.
But will help this part of retaining wall for stability.
Yeah.
Okay? We have two parts, actually. Your retaining wall, we have base and we have stem. I'm talking right now about this part. What is the effect of the soil and the additional load on this part? Later, we will talk about the stability of the retaining wall as a whole part. So we are talking about this part. We have more stability. Okay, wait. Okay. Step by step. Sometimes your soil is dry. We don't have any groundwater on this soil, but probably we have some. Here is the groundwater level or water level, water table level. Should be something like this. So, what is the difference? What do you think? Actually, I will work with water alone. So for water only, I will assume my retaining wall with water only. What is the lateral pressure of water on the retaining wall? At this point, gamma water H equals 0. I'm talking about water pressure. So gamma water, H water. What is the H for water at this location? We don't have H for water. At this location, what is the gamma water H value? We have H for water, H2. So we have a value. We don't have value here. Your pressure will be triangle. I'm talking about only water pressure on this retaining wall alone. So we have a triangle like this for water only. Let's talk about soil. So if you have ground or water table level behind your retaining wall, so I will divide my problem two parts. The first part, what is the effect of water alone, only, and get it. Then go ahead and get the effect of soil. Okay, at this location, what is the vertical pressure? Gamma soil H plus Q, because we have additional load. Actually, I don't have H